All right, good. I'm sharing my screen. Let me know when it is visible. It is visible, right? Okay, good. Now, today I want us now to start with the measures of variability. Okay, as we have defined that is variance, all those definitions were correct. Okay, yes. So why? Let's try and see what is variance. Okay, so that is the term variance refers to a statistical measure. Okay, of the spread between numbers in the what? In the data set. More precisely, variance measures how far each that is number is that is in set is from the mean, and that's every other number in the set. Like for example, let's assume we are having a value which is value x. Okay, we have this value, and this value it's at what? It's at the like it's like the mean of our data. Okay, so and we can plot our other what? The other data points. Okay, we can plot the other data points. All right, so if we plot the other data points, now we are talking about the distance between each that is the mean and what? Each data point, between mean and each data point. Okay, it's like the same thing when it comes to maybe I don't want to talk about that is or to say the error term. Okay, is the same as that is variance. But remember, also when we are talking about error term, like we usually talk about what? Talk about the distance between what? Between the data points and the what? And the line of best fit. Okay, so this deviation, okay, from the what? From the line of best fit, we call error term. Okay, so the same thing now when we are talking about that is variance. Okay, this is our data set, and we can plot other that is this is our mean, sorry, this is our mean, and we are plotting other what? That is other values. Okay, along that is our mean. Okay, so the distance between our data points and the mean, it's now measured by what? It's like the variance. Okay, we are trying to show how far is each data point away from the what? Away from the mean. Okay, yes. So variance is often depicted by this symbol. So variance is depicted by sigma squared. Now, sigma squared is for population. Okay, it's a symbol for population variance. And then this is sigma squared, and then we have s squared. S squared is also variance, but sample variance. Okay, it's also that is sample variance. Okay, like for example, let's try to make a formula out of what? Out of that is our definition. Okay, so let's assume we have our xi's. Okay, xi's, they are our x values, whereby I can take 1 up to n. All right, so we can now try and check, we can calculate mean out of the xi's. Let's assume we have x1, okay, x2, x3, x4. So these are what? These are our values. Okay. Then we can compute mean out of what? Out of these values. So x1 plus x2 plus x, sorry, this is plus x3 plus x4 divide by, we can say n, whereby n we know it is 4. Okay, we know n is 4. Okay, why? These are our i's. We know that is, in this case, I is equal to 1, 2, 3, 4, and it's going up to n, but this is our end value. Okay, so when we compute this, we will get what we call mean, that is the x bar. Okay, so now finding the difference between what, between each between each data point and the mean can be expressed as x1 minus into x1 plus x2 plus plus x3 plus x4 divide by what? Divide by n. But remember, all this, it's equal to what? X bar. Okay, so in that case we can say that the that is the difference, it is x1 minus x bar. All right, then we want to do summation of all these, and then remember we've said that we usually square what? Square that is all these values, just to make it a positive value. Okay, to make it a positive value. So with that, let me just now give you the last okay, good. Now with that we'll say that, okay, or we will conclude that sigma squared, all right, is equals to, this is what? This is mean. Let me just use sample mean. S squared will be summation of I is equals to 1 up to n, okay, of the xi's, okay, minus x bar, all right, you square this, divide by what? Divide by n. And because it's a sample data, okay, it is a sample data, and there is no way in which, that is, the sample size will be equal to population. Okay, if n is equal to that is, if the population is equal to sample, then we don't talk about sample, we talk about the population. Okay, but now this is our sample data, that's why we will have to minus 1. Okay, so meaning, it's like when we are talking about population, it's like we have not considered one value, okay, for us now to reach to what? To the capital N, which is the population. That's why I'm saying that there is no way or there is no point where the sample size will be equal to population size. Okay, that's why for sample for sample standard deviation and sample variance, we usually minus by 1. But if it was population, we could say that sigma squared is equals to summation of I is equals to that is 1 up to n into the xi's minus, now mu, we know mean, that is population mean is denoted by mu, okay, squared, divide by what? divide by n. This is for population, okay? But if we are talking about now sample data, we will have to use n minus 1 because there is no way that n will be equal to what? To n. I hope you got that point. I hope that point was clear. By a show of thumbs up, if you got the point. Why we are not using n, that is n only, but we are using n minus 1, more so when we are talking about what? Sample size. Okay? Then when we talk about population, we use only n. Okay? Right. Like for example, let me just use an example. Let's assume we have a population of 1,000. Okay, so this is our capital N. When we are talking about that is n minus 1, we are meaning or we are talking about that is maybe 1,000 minus 1, which is 999, meaning still this is not equal to, still this is not equal to n. Okay, still this is not equal to 1,000. Okay, so if we take 999 over that is out of that is the 1,000, which is population size, so we can also consider this as a sample. We can still consider this as a sample data. But if we use 1,000, then it won't be a sample. Rather, now it will be that is population. Okay. All right. Good. Let's continue. I hope that was enough. That is illustration. Okay. So variance is often depicted by this symbol. It is used by both analysts and traders to determine the volatility and market security. So basically, this tries to it measures when it comes to finance. Variance measures volatility of some shares or of market securities. Okay, while now the standard deviation we majorly use to do what? Maybe to determine the consistency of that is of the rate of return or to measure risk of a certain investment. All right, so let's go to standard deviation. We are talking about we are saying that the square root of variance is the standard deviation. Okay, meaning we were talking about sigma squared. So that is for that is this is for population, then population, then sigma will be st dev. Okay, that is standard deviation that is of the population. When we are talking about sample size, it will be s squared as to denote variance of sample size, and s to denote standard deviation of what? Of the sample size. Okay, right. So square root of variance is the standard deviation. So square root of this will give us standard deviation. So s, definitely this will remove this and remain with s, and then this will remain as a square root. Okay, all right. So the square root of variance is the standard deviation, which helps determine the consistency of an investment's return over a period of time. So like this is just an application when it comes to assets investment. Okay, or yes, asset investment. So if you invest, definitely you are expecting that is some returns. Okay, now if we that is calculate the returns which you've been receiving from this investment, and calculate calculate the standard deviation given that is given a period of time, then you can see the consistency, okay, or how consistent that is you will your investment gives you returns, okay. Yes. So standard deviation, we've said that standard deviation is a statistics that measures the dispersion of a data set relative to its mean, and it's calculated as the square root of what? Variance. The standard deviation is calculated as the square root of variance by determining each data point's deviation relative to the what? To the mean. If the data points are further from the mean, the higher the standard deviation. Okay, so that is if you have that is a great gap or a big difference between your data points and the mean, so definitely your data will be spread out. Okay, let me just use an example. Like for example, if your data points are that is far away from the mean, so definitely it will mean that your standard deviation will be also that is big. But if your data points are closer to the what? To the mean, okay, so you'll say that the standard deviation will be what? Will be that is somehow small, okay. Yeah, so if your data points are farther from the mean, there is higher deviation within the data sets. That the more spread out the data, the higher the standard deviation. Okay? Yes. Want to drag this here. So I want us maybe to see how can we apply this standard deviation. Okay? So, like for example, we've talked about rate of return, or gives us the consistency, or it measures the consistency, okay, in the rate of returns of or of a given asset. Okay, so the standard deviation, we are saying that the standard deviation is a statistical measure. Okay, it's a statistical measure in finance that, when applied to the annual rate of return of an investment, it sheds light on the investment's historical volatility. Like for example, you will be able to see maybe what risks will you get from that is investment. Does it mean if I invest in this, I will take more time until I regain maybe my that is the value of the asset, and start that is making profit? If the rate of the return is not consistent, then you might re-strategize, or you might decide to maybe diversify, okay, your risks, or you can now buy different shares, okay, depending with the that is the rate of returns, okay. So we are saying that the greater the standard deviation of securities, the greater the variance between that is each price and the mean price, okay, which shows a larger price range. That's why you might hear maybe a certain company is maybe overpricing its shares, okay, or underpricing. Also, overvaluation or undervaluation. That's it's the gap which is created more so when maybe the price of the stocks that is it's far it's far away, or it's on higher side, okay, or lower side, comparison to the what, to the mean prices of the other what, of the other shares. Like for example, when you talk about I guess when you are talking about in that is sh- share prices, we have what we call, I think it's index 500. Like a group of 500 companies come up with what, maybe a certain amount of what, like a certain price of share, okay, but you find maybe a new company is pricing higher, okay, in comparison to the price maybe set by what, by this collection of what, of the shares, okay. Maybe the finance people can explain more on this. I'm not a finance person, but this I can remember learning of these things back in campus. Okay, maybe I might not explain it better, but if we have a finance person here who understands about the stock prices, can maybe give us that is like a more detailed example, okay. But what I'm saying, like, we might have a specific set price for shares, okay, in a market, but you find maybe a certain company, it's that is selling its shares on higher price, okay, compared to this set price. So you might find maybe this company is overvaluing what, that is its shares, maybe to collect money, okay, to collect money, maybe to deal with their external struggles, or you might find maybe another company which is that is which has reduced its share prices, maybe also to attract more funds. Okay, all right. So, for example, a volatile stock has a high standard deviation, meaning it's a very risk stock. Okay, so standard deviation can help us to maybe determine risk, risk of a certain security. Okay, or risk of what, a certain stock. So if we have a big or that is a larger standard deviation, okay, between that is a stock, or between a stock price, then we can say that it is a very risk it's a very risky investment, or it's a very risky stock to buy, okay. Like you might buy it right now at higher price, and then tomorrow you find that is its price has gone down, okay. Meaning in that case, if you had invested more in that stock, okay, or you had put all your eggs in one bucket, then definitely you will suffer a loss big time, okay. But if maybe that's why, if maybe in a market we have that is volatile stocks, maybe some people tend to do what, to use now the diversification. Like now you diversify your risks, you buy some, you buy some that is some shares, okay, which are not volatile, and also, or which are less volatile, and then you can also invest on the what, so that in case of any loss, you don't suffer that is loss in all your investments, okay. Yes, just some takeaways. So standard deviation, we've said it measures the dispersion of a data set relative to its mean. It is calculated as the square root of variance. We've said that standard deviation in finance is often used to as a measure of relative risk or riskness of an asset. we've also said that a volatile stock has a higher standard deviation, while maybe deviation of a marble chip stock is relative rather low. Okay, like the smaller the standard, like if we have a small standard deviation, then we can say the risk of that stock is what? It's also low. So as a downside, the standard deviation calculates all uncertainty as risk. Okay, even when it's in the even if it is on the investor's favor, such as above average returns. Like for example, uh, as downside, the standard deviation calculates uncertainty, or it calculates risks, okay, of investments. Okay, when maybe when it's in the investor's favor, like so standard deviation can basically show us the risk of what, of a certain investment or stock. Variance is a measurement of spread between numbers in a data set. Okay, then the investors use variance to see how much risk an investment carries, whether it will be profitable or not. Okay, so variance is also used to compare the relative performance of each asset in a portfolio to achieve the asset, maybe the best asset allocation. And also we've said that in statistics, variance measures variability from the average mean. It is calculated by taking the difference between each number in the dataset and the mean, then squaring the differences to make them positive, and finally dividing the sum of the squares by the number of what, of the values in the dataset. Any question about any question about standard deviation? Any question about standard deviation? Yes, Susan?
I hope you can hear me.
Yes?
Yes. Because now this is theoretical, when you're covering the practical side,
Sorry?
will we be able, or let me type the question.
Okay. Will we do a practical? For it's not basically about stock, but we'll do using another data. Okay. S- Stock variability was just an example, okay, in this case, but it's not that we'll do. That is an example, or the practicals using that is the finance application. Okay, yes. So because maybe we might lack some data, or maybe we will use whatever it's variable that is available. What's there is just because the calculation is the same. Okay, maybe the explanation it's what is different. Okay, yes. Another question? Elisha, any question? Wangui, any question or addition? David, Steve, Frederick, Gachibi. Gachibi, I guess it's your first time. Uh,
No, sir.
uh-huh.
But good evening to everyone. I joined yesterday.
Okay.
I wasn't able to join on Monday and the day after Monday, which is Tuesday. But I've been following keenly in terms of what you've been presenting. So I'm with you. Thank you.
All right, no problem. Thank you. So, okay, I guess we are all good by maybe by the show of thumbs. Can if we are together before I can proceed to the next topic. Susan, Steve, only two people. I want more thumbs. Okay, those are four. Give me two more. Give me two more. David, are we together? Nice. At least that can be a good sample size. All right, David. Yes, are we together? Hello, we can't hear you if you are speaking. Okay, okay. I've seen your thumb. All right, good. Now let's move to the next. That is slide. Okay, so that is under covariance. Okay, all right. So covariance, remember I've said it runs between negative infinity and infinity, meaning you can get a value of 1000, okay, 10, 6, okay, 30. You can get very many. That is either it can be also negative 100. So you can get what? That is any values between negative infinity and infinity. Okay. Then, what is covariance? So covariance measures the directional relationship. Remember, in my definition, I said covariance shows us more of what? More of that is a relationship. Okay. Yes. So that's why we are saying covariance measures the directional relationship between what? Between the returns of that is on two assets. Like it's either the two assets are moving maybe together or in increasing manner or decreasing manner. Okay. Or this is now we talk about this is positive. Like let's say these they are moving in what, let's say in one direction, and then we have which we call now positive covariance. Okay, and also the two assets might be moving in the opposite direction, and in this case we'll call it negative covariance. Okay. Yes. So please, next week we'll be doing the practicals. Okay, that is next week Monday. We'll be doing the practicals. So please try and also come with examples of that is assets or examples of positive covariance and also examples of what, negative covariance. Okay. All right. Good. Now, we are saying that a positive covariance means that the assets move together, while a negative covariance means they are what? Or they move inversely, as I have explained here. Okay? Even if they are decreasing, provided they are moving in the same direction, we are saying this is also a positive movement. Okay? If they are moving in an increasing manner, they are moving in the same direction. So this is still positive. But if they are moving in the opposite direction, one is increasing as the other one is decreasing, okay, then definitely we'll talk about negative covariance. So covariance is calculated by analyzing, that is at return surprises, or the standard deviations from the expected returns, or by multiplying the correlation between two random variables by the standard deviation. But what I know, that is covariance, we usually say we have a formula for covariance, maybe of two variables. Let's assume it is x and y. Okay, it's given by we have a formula here for covariance is given now by the product, okay, of the summation, or the summation of products of the x deviations and what, y deviations, divide by what, divide by n. You can see here we are taking the xi's minus x bar multiplied by yj minus y bar. Okay, so basically if you do the now the summation of the both, then you will what? You will now get then divide by n, you will now get your covariance. We shall do this mathematically, and we shall also do it that is using an Excel function. When I say doing it mathematically, it's like we'll be doing mostly the way you did in Canvas. Okay, we'll have, that is the x, or the values of y, and we'll have the values of what, or of x and y. Okay, then after that, we'll now compute the mean. Let's assume here we have the x bar, okay, and also the y bar. That is, you had all these divided by the count, okay. Then after that, we will now compute what we have, what we call maybe xi minus x bar, okay, and also y j minus y bar. Okay, then after that we'll do what, now the multiplication, will multiply x i's minus x bar, okay, multiply by y j minus y bar. Okay, then the values which we get here, we will sum them, okay, to get now the summation. Then we will divide by the what? By the count of, that is by the count. So if the n is 10, we are having 10 entries each, then we'll take this summation, we'll take that summation, okay, divide by what? By n, and we'll get what? We'll get the covariance. And then we will also cross confirm our process by doing what? By now using the covariance, okay, covariance function in that is in Excel. Okay, yes, I guess that was clear. Guess that was clear. Let's now continue. Now, in fact, the takeaway should be somewhere here. Let's go through the other notes. It's just about now understanding the what? The covariance. So whatever we've already talked about, it's already here. Okay? Yes. So covariance evaluates how the mean values of the two random variables move together. If stock A return moves higher whenever stock B returns moves higher, then they have the same relationship, or the same relationship will also be found when each of these stocks return decrease. Like if they were moving that is together on the higher side, whenever maybe the one is dropping, the other one will also start dropping. Okay, so then these stocks are said to have a positive covariance. In finance, Covariance are calculated to help us diversify our security audience so that you may not put all your eggs in the same what, in the same bucket. So that's the meaning of diversification. If maybe you can't invest maybe all of your that is assets, okay, you can't invest all of your assets in what, in one that is in one um, like one asset. You can't invest all in what, in one asset. Okay, all right. So let's go now to the other one. So the covariance equation is used to determine the direction of the relationship between two variables. In other words, whether they tend to move in the same direction or opposite directions. Okay, this relationship is determined by the sign, positive or negative, of the covariance. So if we get a negative covariance, then we know those two variables are inversely proportional. They move in the opposite what, direction. Okay, but if you get a positive, then it means these two assets or variables are moving that is in the same direction. All right. So positive covariance. A positive covariance between two variables indicates that these variables tend to be higher or lower at the same time. In other words, a positive covariance between variable x and y indicates that x is higher than what? Average of the same times that y is higher than the average. Like what basically we are trying to mean is that like a positive covariance between two variables indicates these variables tend to be higher or lower at the same time. Like if variable x is higher, okay, then variable y will be also higher. If x will be lower, then y will be also lower. Okay, yes. So basically this is what is it's what maybe positive covariance means. Okay, this is the same thing, I won't repeat this. I've already talked about this. Okay, all right, good. Let's go to what about covariance of zero. If we have covariance of zero, then it means we don't have any clear directional relationship between what, between the two variables. We don't have any clear directional relationship between the two variables being measured. So a covariance of zero indicates that there is no clear direction relationship between what, the variables being measured. Okay, then we have the takeaways. Maybe just want us to go through the takeaways, and then we can finish with that is correlation. But correlation I'll just cover this first slide, and this second slide maybe I will explain in the next class. Okay, before we can do what, before we can start the practicals. Why? Because I don't want to rush in the name of that is completing the content. Okay, I also want us to go together, make sure you understand. Okay. In fact, for the correlation topic, we will handle it next week. Okay. So we'll just go through the key takeaways that is of covariance, and then correlation now we'll discuss in the next class, then do the practicals for what, for all those topics from 1 up to this. Okay, all right. So some takeaways. So covariance is a statistical tool used to determine the relationship between movements of two variables, which is true. When two stocks tend to move together, they are seen as positive covariance. When they move inversely, the covariance is said to be negative. Very correct. Covariance is different from the correlation, okay, coefficient, as correlation, okay, tries to measure the strength of the relationship, okay. So covariance is significant tool in modern portfolio theory used to ascertain what securities to put in your portfolio. Okay, like it trains you more, or it makes you know when to do what, to diversify your risks. Okay, then risk and volatility can be reduced in a portfolio by pairing what, assets that have negative covariance. So assets that have negative covariance means, or that is, they can't be affected by what, by one factor. Okay, like if we have that is one factor which is affecting certain group of shares, okay, or assets, then you also have another group which is not what, which is not affected. Okay, and that marks the end of my class, unless now you have questions.